Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
How are you? Okay. All right. Now today the weather is not very good at my area. So my house, if there is a thunder or lightning, probably disconnected. So if there is a disconnection, okay, internet, you stay, okay, don't go. It may take a few minutes because now ada ni peti, mungkin ada peti atau ribut atau ni kilat. So we may have disconnection, but you stay, okay? I will connect again. We will be fine. Rumah saya cepat tendang elektrik. Saya pun tak tahu pasal. Okay, today what I will do, my plan for today, we will do this. We will look at application of the derivative, first derivative. That means we go back to 9.4, 9.5, and then the application will be 9.9. But we will start from the beginning, and then I will look at the relationship between the derivative and the function. What we call this will be the first derivative test. We will look at the behavior of the y prime derivative, and then how that will relate to the behavior of the function. So that will be our plan for today. Now let's look at application. Application for this part would be how we apply the derivative. Now the application will be similar to the first topic, the linear function, where you have the slope equal to delta y over delta x, and we interpret it as whatever we interpret earlier. So that would be the basic application. Okay. So now we're going to do here, we're going to look at application of the derivative. So that is what we plan for today. Now I want to see. Was the recording on ke tak on? Okay. So application.
Oh, ini Yuki.
Oi, diam. Don't talk. Okay, don't talk, please. If you want to talk, mute the video. Okay, I turn on the video, so that's easy for you to raise anything. But don't talk nonsense. Okay. If you want to do that, please mute. Okay. Now application. How we apply the derivative. So we look at the function y equal to f of x. The derivative is y prime equal to f prime of x. Now, when you do the derivative, we look at the notation dy dx. Because here you will see a small change in x, all right? And then there will be a change in y. So that will define the change of y with respect to a small change in x, okay? And that will relate to the basic basic notation delta y over delta x. Siapa tu? Wait. I said if you want to shout or make noise, please mute. Siapa tadi tu? Okay, so that's the application that we're going to look at. So now, okay, application. Itulah, when I heard that kind of sound, I forgot what I wanted to say. Aduh, Dajjal mana tu? Bising betul lah tadi tu. Kalau nak bising, jangan masuk kelas dululah. Alright. this is the idea, okay? The idea of application of derivative. So you have y equal to fx, the derivative is y prime equal to f prime of x. So that is the idea of application. So we're going to look at the application, okay? Look at 9.4, 9.5. Basically, application would be the revenue, all right? Revenue, cost, and the profit. We're going to look at these functions, take the derivative, and what is the derivative? So let's say we start with the revenue, and of course, we want to relate back to the function and the derivative. So if you look at revenue, revenue is a function of x. Now the derivative of the revenue, what is it? It's r prime equal to dr dx. Okay. Now, if you recall, in the linear function, okay, for linear function, r prime equal to delta r over delta x. Now, what do we call this? The change in revenue for a unit change in x. What do you call the marginal what do you call what do you call the r prime, not r prime? I'm sorry. From the linear function, okay, you got the slope, m equal to delta r over delta x, and that is, if you recall, equal to the price. Well, now what do we call this thing here? Delta r over delta x. Anybody remember? That's what? It's the marginal revenue. Okay, so that's marginal revenue. So similarly here, this delta r over delta x, dr over dx, that's the change in x, and then what happened to the r? So that is called what? That is called the marginal revenue. So the application, the basis would be similar to the concept of the slope. Okay, the derivative r prime dr dx is the marginal revenue. And then if you look at cost, similarly the cost. Cost is a function of what? Cost is a function of also output. And the marginal cost, C prime, is dc dx. That is called the marginal cost. And profit, okay, you say h of x. The derivative is p prime. You call it dp dx. What do we call it? That is what? That is marginal profit. So for the derivative, or for the function, and you get the derivative would normally we call, okay, in economics, marginal of whatever the variable we're talking about. So derivative is what? The marginal, just like the slope. All right? Because why? Because the slope, we think of it as the derivative, the slope at a point. So that's related to the slope. Okay? It's just that now we're talking about slope at a point. All right? So again here, if you look at the function in economics, y equal to f of x, normally the derivative of y equal to f prime of x equal to dy dx, we call simply marginal. Okay, marginal revenue, if it is a revenue function. So it's marginal of y. Okay, whatever the y is. For example, we'll talk about revenue, cost, profit. Okay, so in terms of application, the marginal is just like the slope. Okay, all right. So that's the idea. So now let's look at 9.5, the example number berapa tu? Example on the revenue, I think 9.4, 9.5. Let's go to 9.4. 9.4, no, 9.5. We start with 9.5. Yeah, I think it's 9.5. 9.5. Let me check again the function. Okay, yeah, 9.5, it's example number 4. Okay, so first example 4, 9.5. So if you look at 9.4, there is a marginal revenue. You know, same thing, the derivative of the revenue. And then 9.5, you still have example revenue. So derivative is marginal revenue. The only difference here will be the rules. They have the same example, you know, with different function, with different revenue function. I'm sorry. Example 9.4 and example 9.5. We are talking about different kinds of rules. Here we are looking at the quotient rule. Over there is just power rule. All right. So again, you know, it's about same concept. Now let's look at example number 4. You have the revenue function as given in that example. I will want to find, all right, you want to find the marginal revenue. But first, okay, as we do when you do the application, you have to be sure of the X and revenue. Now, what is X? X is what? Is flash driver, flash drive, not flash drivers, flash drive. So here X is flash drives. Okay, flash drive in units. And then you have the R, which is in dollars, the revenue. Okay, revenue. Now, I want to make a comment here. We'll go back to the homework. All right, the homework number 1, which you submitted to me. Now, when we do application, you have to specify the variables. Okay, you have to specify what is X, what is Y to the relevant application. Okay, and then the units. Now, for the example that we have, not for the example, for the problem homework that you have, some people do not specify anything. Okay, you just jump to the cost and revenue. Okay, at least you have to mention, you know, what is X, what is Y, and then what is what is X and Y, and what are the units. That's number 1. Number 2, you start with Y equal to F of X. Of course, you find the M, you find that B, and then at the end, that becomes cost equal to MX plus B. So there is no connection here. Okay, what you need to do here, of course, if you specify the X and Y, whether, or in this case here, X and C, then you will come up to here, to the cost function. But what you did was not all, you know, a few people, a few groups, you do everything in terms of Y and X, and then at the end you write the cost function. So where is the connection? So we don't specify, okay? So make sure you check your homework again. If you do this, make sure next time, okay, you have to specify the variables. For application, just specify, all right? So when you do this kind of work, you know, take some time, you know, don't jump, okay? Don't jump into doing things. Specify, okay? So that is homework on the some comments on the homework, all right? Because when I look at this, I remember the homework. So if you look at this example, you have the flash X in units and then the revenue in dollars. Now you have the revenue function, you want to find R prime, which is marginal revenue. And that is equal to what? That's equal to 10 plus. Okay, the second term, how do you get the derivative of the second term? You have 100x divided by 3x plus 5. How do you do that derivative? What rule do we apply?
Quotient rule.
You apply the quotient rule. Okay. Now I want you to do it. Okay. I give you 2 minutes. Do the quotient rule. So don't worry about the first term. The first term is very easy. You take just the second term. Okay. Do it separately. Get the answer and then put back into the revenue. So you can use y equal to that ratio, and then apply the quotient rule. Get the solution. Because in the book they give you already the answer, but please do that. I give you 2 minutes. Okay, do it now. Do the quotient rule. Ah, okay. It's nice to see some people turn on the video. Now, what happened to these people? Yusra, Sophia, you know, where are your pictures? I said, put your picture here. Okay, how many times do I have to mention this? You know, Penat, I'm tired of saying the same thing over and over. You know, there are many people here, Fauzia, who have not put on their pictures. One Zadatul, Zeti Ayub ni, put your picture. Do you understand what I said? Huh? Or were you absent when I make the announcement? Irfan Shafiq, or Mina. Okay, so please put your picture. Sajat, tak faham ke? You know, I told you a few times already, put the pictures, please. Dayang Fatin, is this you? Are you human or you a flower? Okay, put a picture of yourself. Alright? Takkan nak cakap banyak kali, penat na tu. It's tiring, you know, to repeat the same thing many times. I think we are big enough. So please, okay, for those people who have not put their picture yet, please put your picture. Okay? Okay, now, go back to this example. What is the derivative? So what you do, okay, we just let some function, say y be equal to the second term. So let's say you got y equal to 100x over 3x plus 5. So we apply the quotient rule. So you let x be 100x. No, I'm sorry. You let u be equal to 100x, and then u prime equal what? Equal to 100. And then you let v be equal to 3x plus 5 plus 5. Then v prime is 3. And you know the quotient rule. Okay, the quotient rule says what? U prime v minus v prime u, everything divided by v squared. Now you put in everything, but you get, I get u prime, which is 100, multiplied by v, 3x plus 5. Okay, and then we minus. Okay, so make sure you have a minus sign over there. V prime, 3, multiplied by u, which is 100x. Everything divided by 3x plus 5. Okay, so if you can see here, 100x times 3, 100x times 3, 100x times 3. So 300, take away 300, so that we cancel out, so that becomes 500 over 3x plus 5 squared. So that is the derivative of the second term. So now it's good, okay? If you have this kind of function, which is quite long, for the quotient rule, it's good that you do it separately first. Okay, do it separately like what we're doing here. Then only you put into the original function, the derivative. So therefore, our r prime will be equal to what? Will be equal to 10, okay, derivative of the first term, plus 500 divided by 3x plus 5 squared. So you see here, you are organizing your solution nicely. Rather than you do everything right away on the revenue function, you know, it can become quite messy. So you got that. And then what do you want to do for the next part? Well, the next part, what is the marginal revenue at x equal to 15? So at x equal to 15, what is the marginal revenue? So what do we do? How do you find the marginal revenue at x equal to 15? How? Anybody? Where do we substitute
the x
into what function?
into the x into the r prime.
Substitute into the r prime. Okay, so we substitute x equal to 15 into r prime, which is the marginal revenue. Because you want to find the marginal revenue. If you want to find the revenue, then we substitute into the revenue. So if you do that, at x equal to 15, okay. Okay, Siti Nomai Sarah, tu bunyi apa tu? At x equal to 15, okay, at x equal to 15, what is the marginal revenue? equal to, if you look at the book, they give you the answer already, that is equal to 10.2. Okay, from the book. So you work out lah. So that is the marginal revenue. So now, next part is, how do we interpret? Okay, how do you interpret the marginal revenue, correct, which you get from the derivative? Now, when you want to interpret, we want to use this R prime, which is the marginal revenue, equal to dr, dx. That means, what happened to the revenue if x changed by a very, very small amount, all right? Now, in reality, in application, you don't have change or very small change in x, okay? You don't have a very small change in x. You don't have x changes by 0.000001. In application, if you are producing like here, the flash drive, or you're producing a car, or you're selling burger, what is the smallest unit that you change your output, your product?
Is it one, sir?
1 unit. So in application, the smallest is 1 unit. All right. So dr dx, when you do the application and you want to interpret it, we go back to the first topic. When you do the interpretation, you use the delta y over delta x. Okay, approximately. So here you think of it as what, delta r over delta x. We are looking at, a unit increase in the x, or unit change in x. So 1 unit change in x. Okay, 1 unit change in x, either increase or decrease. And then what happened to the y? Okay, so in this case here, what happened to the revenue? So go back to the first topic, linear function. If you recall, okay, let's say we have the delta r over delta x, which is the marginal revenue. Suppose it's just equal to that answer that you got, 10.2. Now, how do you interpret this thing here? Anybody still recall that thing? How do you interpret in terms of 1 unit increase in the x?
When x increase by 1 unit, the revenue will increase by 10.2.
So we use that concept, all right? So here, when x increases by 1 unit, all right, the revenue will increase by how much? By $10.2. Now, if this x is equal to, as we already know, it's the number of flash drives in unit. So you can say when flash drive, all right, when the number of drives increases by 1 unit, revenue will increase by $10.2. So we interpret it, or we describe it in terms of the specific output or good. So here you have a flash drive. So you can say when we produce 1 more unit of flash drive, or you can say, sometimes when you look at this thing in terms of application, sometimes it's good to say when you produce 1 more. Okay. So when you produce 1 more, okay, 1 more unit of drive, revenue will increase by $10.2. Or you can just say when the number of drive increases by one unit, the revenue will increase by 10.2. All right, so that is the basic. So when you interpret, you use the basic concept because the minimum number or the smallest change is 1 unit. All right, okay, good. Now, let's look at another example. Not another example. The revenue at x equal to 50. So when x equal to 50, what happened to the marginal revenue? Or what is the marginal revenue? Okay, can you get me the marginal revenue at x equal to 50?
$10.02.
10.02? Okay, 10.02. Dekat juga dengan ni. Dekat juga dengan 10.2. Okay, try another one. Try X equal to 20. Cuba tengok 20. 20. You tengok 20. Berapa dapat?
Ten point one two.
10.12. 10.12. Okay. So here 10 point berapa tadi? 50, 10 point berapa?
02.
02. When 20 R prime equal to 10.12. Okay, alright lah, tak apa lah. So the thing here is, if you look at the marginal revenue, what can you say the marginal revenue at different x? X equal to 20, X equal to 15. What can you say about the marginal revenue?
Different.
Different. So here you have a nonlinear function, okay? Nonlinear function, the value of the derivative will be different. Different everywhere. So different value of marginal revenue or different value of the derivative at different point. That one we know, all right? So what you need to do here is that when you want to interpret, of course, you want to base it on the basic interpretation, but it is not enough. You have to add another statement, all right, that contribute to the difference in the value. Now, what is the thing that contribute to the difference in the value here? Here you've got 0.02, and here you've got 0.12. Earlier you've got 0.3, 0.2. What make the difference? What causes the difference?
The production of first drive, sir.
The value of the X, okay? The production of the drive. So you have to mention, all right, what is the level of production, okay? So here you just add another statement. At X equal to what? Equal to 30. You have to state, okay? You have to state where is the derivative taken at? What level of output or what level of X? Okay, or what value of X, or you can say at what point, okay? What point do you take the derivative? Because that point will influence the value of the derivative, okay? So here, when X increases by 1 unit, revenue will increase by 10.2. You have to say at X equal to 30, or when X equal to 30, or given current production of drive at 30 units. Or you can say given, okay, given production of drives at 30 units. So you have to state, okay, you have to state the point of the derivative. Okay, all right. So let's interpret it. Interpret yang ni pula. At X equal to 50, how do you interpret the marginal revenue? Anybody?
When X increases by 1 more unit, the revenue will increase by 10.02 at X equal to 50.
Okay, everybody got that? So you have to state, all right, where is the derivative taken at? But interpretation will be just similar to the earlier interpretation. So here, when we increase production of drives, or you just say X increase, you know, or when the drive increases by one more unit, then what happens? Then the revenue will increase by $10.02 given or at X equal to 50. So or given the output level is 50. Okay? Or you can just say when drive increases by 1 more unit, the revenue will increase by $10.2, $10.02 at X equal to 50. All right, so you have here another statement that you have to add because it is a non-linear function. If it is linear function, like what we were talking about at the first topic, there is no problem, right? Because everywhere the slope is the same. So it doesn't matter, where your point is, doesn't matter, you still have the same slope. All right. So our interpretation here is the derivative is slope at a point. But interpretation will be just like we were doing. Okay, any question? So you have 9.5, that is on the marginal revenue. All right. So I give you a few questions, on 9.5. So 9.5, you can try doing question 42, that is on the revenue. You see a different kind of function. And then 43, again, revenue, and then 48. Okay, try to do number 48 on the advertising and sales. Okay, any comment, any question? Okay, now let's move on. Now I would like to look at another example. The other example is on the marginal cost. So go to, let me see, is there any example on the marginal cost? Okay, if there is, I don't see an example on the marginal cost. They don't have it. So please go to 9.9. The 9.9, they will give you the application. All right, that section is solely focused on the application of the marginal revenue, marginal cost. So I give you the question 9.5, question 42, 43, and 48. All right. Now let's move on to 9.9. Again, here you will see the marginal revenue, marginal cost, and the marginal profit. So let's start over with the revenue function. And here, all right, here, there are two types of market. So we start with revenue. And of course, revenue is a function of X. And then you want to find the derivative that is the marginal revenue. And I write the R, the X. Okay, now, there are two types of market. One is where you have perfect competition. And then the other type of market is monopoly. Now, in perfect competition, the price is given. It means the price is constant, okay? So this one, we already knew. You have, revenue is equal to what? Revenue is equal to P times X. Say P is equal to 150. So therefore, our revenue is simply 150X. This one, we know from the linear function. Because price is given, so that kind of market is perfect competitive market. Price is given, okay? Now, on the other hand, if you have a monopoly type of market, what is the difference? Anybody who has taken principles of micro, what is the difference between the firm, the behavior of the firm with respect to the price in perfect competition and monopoly?
The price in monopoly market is based on the seller. The seller is the price.
The seller has influence on the price. Okay, so here in monopoly, the price is not a constant. The price is a variable. Okay, the price will change. All right. Now, when you have that, again, the revenue is still P multiplied by X. But that P is not a variable. No, I'm sorry, P is not a constant. P is a variable. So P would be given by the demand function. Okay, demand function. So demand function, you have P as a function of X. Okay, I will use another letter because I have already revenue function of f. So let's say P is a function of x, D of x. And that demand function, for example, is equal to 100. We look at the book, go to example number 1. We just use that example. Will be 16 minus 0.02x. So equal to 16 minus 0.02x. So that is our demand function. All right. So from here, you will get the revenue. So you substitute this thing here into the revenue. Okay. You substitute. What do we get? You get revenue equal to 16 minus 0.02x multiplied by x. So that is our revenue function. So you multiply that out, we get 16x minus 0.02x squared. So that is our revenue. So you see here in monopoly, the revenue function is not a linear function. Revenue function is non-linear. Okay, so here you've got a non-linear function. Because the price is not constant. The price is a variable. Okay, so in perfect competition, revenue is just a linear function. Monopoly, non-linear. So, when you see a non-linear function, that means the market is what? It's not perfect competition. Okay, it's monopoly. So that would be the, the function for a monopoly firm and a perfect competitive firm. All right. Okay. So again here, if you look at that example, you have the revenue function. Okay. Go to example number 1. You have the revenue equal to 16x minus 0.02x squared. So the marginal revenue will be easily computed. Okay. You can determine very easily. And again here, you can determine the marginal revenue at the particular point. So if you go to that example, I just follow the book. Now at x equal to 40, you can see here the marginal revenue or R prime equal to dr dx equal to what? Equal to 14.4. Okay. Now I want you to interpret this. So you go to that example, see what is the unit for x, if there is any, and then what is the unit for the revenue. So I would like you to interpret the marginal revenue at x equal to 40. Okay, I want everybody to write down. Okay, please write down the interpretation in terms of the unit of the x and what is the the interpretation. Okay, go ahead, do it now. I give you 2 minutes. I want everybody to write down and then you read what you have. Ni Yusra. Yusra 2019810. Masih di mana Yusra? Apa saya ada 2? Okay. Okay, Yusra. Interpret the derivative. Yusra, are you here?
When X increased by one unit, revenue increased by $40.4 at X equal to 40.
Betul ke tak betul? Everybody, anybody? Is that right or is it wrong?
Right.
That's right. Okay. You have to mention the current level of production. And then when X increases by 1 unit, the revenue will increase by $14.4 at X equal to 40. Okay? Okay, good. So, tadi siapa? Yusra ya? Yusra, letak gambar Nanti saya tengok lagi nama ni mesti ada gambar. Gambar tak ada ni. Saya tak kenal siapa. Okay, so there are people who still don't put picture. Alright, so that is revenue. Okay, now we look at the second example, cost. Okay, so cost would be example number, you have here example 1, the revenue. Example number 2 is on revenue, so you can just read those. Example 2. Okay, the second one will be the cost. So cost is the function of X. And here we are looking at non-linear function, all right? The concept will be still the variable cost plus fixed cost, okay? But here it's non-linear. It's more general, you know? So it's more general. It can be linear, okay? It can be linear or it can be non-linear. So when you talk about the cost, the concept of cost will be the same whether you're talking about perfect competition or we're talking about monopoly. Okay, the cost will be similar. Okay, the cost will be the same. So don't worry about the cost. The cost will be either linear or non-linear, and regardless of whether in perfect competition or monopoly. All right. So if you look at that example number 3, you are given the cost function. Okay, so given the cost function, if you look at the one that you have on the top part, you have a linear cost function, so very easy to get the derivative. Look at the example number 3. Okay, example number 3, you are given the cost is a cubic function. What is the marginal cost? So to get the marginal cost, you take the derivative. So what is the marginal cost? C prime equal to the marginal cost. Take the derivative of that function. What do you get? You get 0.003 x. I think you have a cubic function. It's quite easy to do the derivative. Then you got 0.6 x plus 32. So that is your marginal cost. And what is x? Okay, we should specify the x before, you know. So anyhow, let's do it now. So what is x? Anybody? What is x?
Number of kitchen blenders.
The x are blenders or kitchen blenders in unit. Okay, just unit. And then the cost is again here in what? Dollars. Okay, so you know the units of x, you know the units of the c, and then you can interpret. So if you look at that question, you want to find the marginal cost at 80 and 200. So let's change the number. Suppose the x is x at 150, oh no, 65. And then at another point, say 300. Right, I want you to find the marginal cost at these two output level. What are the marginal costs? First, x equal to 65. Second, x equal to 300. Okay, now to save time, for those people, your name is M, A up to M. You do the first one. Your name is N up to Z. You do the second one, and then you share. Okay, do it now. Find the marginal cost at these two level of x. Okay, the first person who get it, let me know. And tell me the marginal cost at what level of output. That's right.
At x at 300, the
Okay.
marginal cost is 1 to 2.
1, 2, 2. Okay, anybody who get the value of the marginal cost at 65? Okay, 1 to 2. Is this correct? Anybody who get the different value? A different value. So good, huh? So that's correct, huh? Okay, the 65. Anybody get the value yet?
$5.675.
Okay, can you repeat? I cannot hear. It was not very clear. Apa dia?
5.675.
5.5675. So kita
675.
okay 675, 675, 675. So we round up to 67 je lah. 675, so 68. Okay, so 5.68. Now, betul ke tak betul ni? Anybody who get a different value? So that's correct, huh? Okay, so good. So now, how do we interpret this? So here we are talking about marginal cost, all right? So again, you use the concept as per the marginal revenue. So what you got now is that the marginal cost is equal to DC dx. Now, when you want to interpret, you think of it as the delta C over delta X. We are looking at 1 unit increase in the X. Okay, so I wanted to write the interpretation of the marginal cost with the unit, all right, with the unit of the X and the C. Now, again here, some people write the first one, some people write the second, as Nila, as your name. Okay, do it now. I'll give you 2 minutes. So write the full interpretation of the marginal cost. So whoever get it first, don't worry whether it is wrong or it is right. I want you to mention to us, and then if it is wrong, then we can make the correction. If it is right, then it's good. Okay, anybody got it yet?
Yes, sir.
Okay, good. Go ahead.
So when we produce kitchen blenders 1 more units, the revenue will increases by $122 at X equal to 300.
Okay, so I write down here. If X, or if the number of blenders, okay, so I think you said blenders. If the number of blenders increases by 1 unit, okay, revenue will increase by $122 at X equal to 300. Okay, is that right or is that wrong? Okay, if it is wrong, what is the correction? What should be the right thing?
Substitute revenue with cost.
We are talking about cost. Okay, we are talking about cost. So it should be what? Should be cost. We're talking about marginal cost. Okay, did you get it? You are right. You know, everything is correct except that here we are talking about the cost function. Okay, so the cost function, that means we are looking at the marginal cost. So marginal cost meaning the cost will increase. Okay, everything else will be correct. All right, just the the revenue shouldn't be revenue; it should be cost. Okay, all right, good. Okay, for this one, the one that X equal to 65. Anybody who want to say? Anybody name? Okay, go ahead.
When produce one more unit of
No.
blenders.
Sharifah, you are doing the second one. The first one ni bagi orang lain. Okay. I want the people from A to M. Okay, because we want to do that now. All right. So Sharifah, you wait. Okay. You want to make the correction later on, you can. Okay. Anybody from A to M?
When blenders increase by 1 unit, cost increase by 5.68 at x65.
Okay. Is that right or is it wrong?
Correct.
Right lah. Okay. So basically, if the number of blenders increase by 1 unit, the cost will increase by $5.68 at x equal to 65. Okay, so that's right. So that's how you interpret. All right, you have to mention the point where you take the derivative. So that is our second example, the marginal cost. Now the third example is profit. And profit, as you know, again here, this is not a new example. It's again example that we have come across, but the only difference now is we use the derivative, which is a more general method, for nonlinear function. So if you recall, what is profit? Profit is equal to what? Revenue minus cost. Okay. So here you have to find the revenue. All right. You have to find the revenue. And of course, you know already revenue. Revenue can be from monopoly or from the perfect competition. So if you look at the example 6, okay, example 6, that is where you have the marginal, the profit. So if you look at the example number 6, what is the revenue here? You have to find revenue. Revenue is PX, all right? Regardless of whether it is a monopoly market or perfect competition market, it's PX. So in this example, are we talking about perfect competition or are we talking about monopoly?
Perfect.
Perfect competition. Why? Because price is given. Okay. So given the price equal to 200, so that would be 200x. Okay. So you know the revenue is just a linear function. Now look at the cost. So cost is equal to what? How you find cost? If you look at the example, what is given there? You are given what? You are given cost per unit. Cost per unit is average cost. Okay. AC. So how do you get cost from average cost? Or let me ask you another way. If you are given the cost, okay, C, how do you get the average cost? I think that one is easier to get. How do you get the average from the total?
The total cost.
You divide by the X. Is that right?
Yeah.
So now, if you are given the average cost, I want to find cost. So what is it equal to?
Multiply.
Multiply. So C is equal to the average cost multiplied by the X. All right. So here given your average cost is equal to 80 plus X. So your cost is equal to the average cost multiplied by X. Given the average cost is 80 plus X. So you put in the average cost multiplied by X, you get that function. And that is equal to 80X plus what? X squared. So you got the cost function. I already have the revenue. So therefore, the profit is equal to 200X. Take away, okay, the cost. Now make sure you bracket for the whole terms, of the cost. If you miss the bracket, so that means sometimes, we may make the mistake. So plus X squared. So now you can simplify. That will be equal to 120X minus X squared. Okay. Okay, now take the marginal revenue. The marginal profit. So differentiate the profit, you get the marginal profit. So what do I get? It's a simple function, here you just use the power rule. So you get the marginal profit. Okay, what is the marginal profit? So P prime is equal to what? Okay, tell me, what is
120 minus 2x.
P prime is equal to 120 minus 2x. Okay, so now let's find the marginal profit at a few level of x. Say x equal to berapa? X equal to 270. And then x equal to 66. Okay, again, to do this quickly. Ini A to M buat ni, N to Z buat tu. Okay, now quickly, because the function is quite simple. You can get it in 30 seconds. Okay, anybody who get first, let me know. Okay, cepat lah. Anybody? Hey, lambatnya. Anyone who get it first, let me know, so that we don't have to wait for too long. Berapa?
I got the P prime is -2, sir.
For which one? The first one?
For the x, x at
270.
66.
66. 66 berapa?
-2.
-2. Okay. 270.
minus 420.
-420. Okay. Ini -2 kan. Kita tukar-tukar. Sebab ni dah minus. So I want something positive. So here change the number. Make it 46. I think 46 dapat positif. Okay, can you do that? 46, berapa?
28.
Berapa? 28.
28.
Okay, 28. Okay, so for the first value at 420, no, I'm sorry, at 270, the marginal profit is negative 420. At x equal to 46, the marginal profit is 28. So I think that's good. One positive, one negative. So interpret. Okay, interpret now. I give you 2 minutes to interpret. Now here, if you do the 270, make sure that is a negative sign here, a negative 420. So be careful with that. Okay, anybody got it? First, let me know, or you just say it. Okay, Fadil Tariq. Fadil Tariq, that means you are doing the first one. Okay, interpret the marginal profit. Fadil pula. Fadli. Are you here? Sorry, silap sebut. Tak nampak LI tu, I thought Fadil. Fadli. Can you do that? Fadli, are you here? Tidur ke pula ni? Okay, Fatin Aina. Okay, Yani.
If the product 270, the profit is negative 420.
Okay. So at X equal to 270, the profit is 420. Woi, jauh betul ni. Fatin. Buat balik. Ini salah jauh ni. Okay, anybody who can, okay, Hasbul. Okay, can you make the correction? Fatin, thank you. Okay, thank you. That's a good start. However, that is wrong. Okay, the only right is X at X equal to 270. Okay, Hasbul, make a correction. Hello, Hasbul, ada ke tak ada? Okay, cepat. Okay, Hasbul tu tak apa. Okay, siapa-siapa lah? Anybody from A to M. Can you
So can
do?
I?
Okay, sure, go ahead. Siapa nama ni?
If Dayang,
Okay, Dayang, go ahead, Dayang.
if the X increased by one more unit, the profit
Okay.
will decrease at $420 when X equal to 270.
So everybody hear that? Okay, one more time.
If the X increased by one more unit, the profit will decrease at $420 when X equal to 270.
Okay, so the marginal profit is negative 420. So that means, you know, if we want to make the interpretation, we relate back to the delta P over delta X, all right? One unit increase in the X, the profit, since it's negative, that means we decrease. Decrease by how much? Decrease by, I forgot the word by here, by 420, where? At X equal to 270. Okay. Now, in this example, what is the unit they give you for the product? Is there any? Are we talking about a proper product or no? Tak ada. Oh, tak ada. So tak apalah, kita just say X. Alright. So negative mean decrease. So if you have anything that has negative, that means the dependent variable will be decreased. Okay. Alright. Good. So for the 46, I don't think there is a problem. We just go by what I have here. If X increases by 1 unit, the profit will increase or decrease?
Increase.
Will increase lah by $28. At X equal to what? X equal to 46. Okay, so that is the interpretation of the marginal. I think we did quite already extensively the interpretation. I hope, you know, if you are not clear, you go home, just review the thing. So that's the marginal profit. Now let's look at the profit function. Okay, and you want to say something? Anybody? All right. Now let's look at monopoly. Okay, for monopoly, the profit would be, or the profit is, you know, there is no difference, equal to R minus C. And suppose we are looking at the same cost, C is equal to the one that we have in that example, which is 80x minus x squared plus, I'm sorry, plus. So cost is like that. And suppose, okay, revenue is equal to PX, and we are looking at the monopoly market, and the profit, okay, profit, no, not profit, the price for which we get the revenue. Let's use the one that we have earlier. The price equal to 16 minus 0.02x. So when the price is a variable, we are looking at what? We are looking at the monopoly market. So how do you get the revenue? So therefore, your revenue will be equal to 16 minus 0.02x times x. You got that? and you, of course, you find the revenue, and then you can get the profit equal to whatever. Okay, so I want you to go home, finish this up. Okay, get the profit function for the monopoly minus the cost, all right? And then you get the profit function. I want you to find the marginal profit. And again, get the marginal profit at x, say x equal to 20, and one more number, say x equal to 150, and then interpret. Okay, so that's your homework for just for your practice. All right, okay, good. So for 9.9, I would like to assign to you some questions. So 9.9, I would like you to do some questions. Number 3, okay, that is on the marginal revenue. And then number 5, you are talking about the marginal revenue for monopoly. And then you can try number 6. Okay. Is there anything else? No. So number 6, where you will get the profit as well. So you do. No, they give you the profit. They give you only the revenue. Or mana yang profit? Okay, we do one profit. Okay, that's revenue. Lepas tu cost. So I didn't assign to you the proper question. So do number 22. That is on the cost function. Okay, cost. And then on the profit, you do question number. You are given the profit. That means look at 28. Okay, 28. And then one more. I want to find a monopoly. Semua dia tak ada monopoli. Dia banyak bagi apa nama tu? Perfect competition. So I give you 22, 28. And then some of the questions they give you already the profit function. So profit function, you do the question number 34. Okay, do number 34. Okay. Now number 28 though. Okay, number 28. They give you the price. So for 28, all right. For 28, you do demand function. Let's say, okay, I base on whatever you have here. Let's say the price now equal to 20 minus 0.05x. So for that question number 28, we make it as a monopoly market. Demand function is equal to what I write here. Okay, Paham? Do you understand what I mean? So for 28, use this demand function. Okay. So that you get monopoly. Okay. Tak payah, you don't have to use the 46x lah. Use the demand function as per note here. All right. So for the question number 28, you use that demand function. 20 minus 0.05x. So that is monopoly. Cost function stay the same, and see what happened to the marginal profit. Okay. All right. Any question? So that that will be dah cukup. Okay, we're done. So next, all right, next, whatever time that I have left, I would like to do the relationship between the derivative and the marginal the derivative and the function. Oh, yeah. Okay, the relationship between the derivative and the function. So this is what you call the first derivative test. That means you want to relate, okay? You want to relate. So here I give you this general idea first, right? We want to relate the behavior of the f prime of x or y prime to the function. How does the behavior of the y prime relate to the behavior of the function? Okay, all right. So let's look at a few examples. You want to see, okay? You want to see the derivatives here. So now let me draw. I think what I do, I will. I think I will erase this here. Okay, we know that we know what we're talking about already. So I want to draw a bigger picture. So let me take that out. All right. So let's say I have a function looking like this. Okay. So you have a function looking like that. And y equal to f of x. This is x, that's y, and that's the 0 point. Now, if you look at a curve like this, what you want to do here is you want to identify, okay, identify where the y prime is positive, y prime is negative, y prime is 0, okay? So you want to identify the area, okay, the place or the region or the interval for which the y prime is positive, bigger than 0, negative, less than 0, or 0, all right? So let me do that. Now, if you look at this area on the left, all right, on the left side here, I draw the derivative. Derivative as a slope at point. Okay, and then I go to, okay, I draw another line. And then I use black lah. All right, now on the left side, here, on the left side of the curve, what can you say about the derivative? What can you say about the slope at each of the point?
Positive.
Positive, okay? The y prime is positive. You see the slope of the straight line is positive, all right? So here you see y prime is positive. Okay, on the other side,
Negative.
Negative. You see here y prime is negative. Okay, now between the area, okay, the interval where the y prime is positive, y prime is negative, there is one point, okay, this is the normal situation where you have y prime equal to 0. Okay, here, y prime equal to 0. So that point is quite important. You call that point as what? As the turning point, or you call it critical point. Critical point or turning point. So where the y prime is equal to 0, call it x0, that would be called the turning point. Okay, when x equal to, at that y prime equal to 0, the value of x is x0, the value of y will be y0. So you call that x0, y0 the critical point. All right, but for this one, you need the interval. You just need to consider the x. Don't worry about that y. All right, so here you can break out the curve in terms of the derivative into intervals. Based on what? Based on the y prime positive, y prime negative. Okay, and of course, the critical point, okay, that will divide the intervals will be what? Will be the y prime equal to 0. And say that happened at x0. Okay, any question? All right, consider another example. Let's say I have another graph here. I draw another graph over here. Okay, this is y equal to f of x. Okay, so again, I look at the curve here. I put the derivatives, the slope at point. And then I look at the other side. And then there will be some point here where f prime equal to 0, and say that will happen at x1. Okay, now you look at the interval on the left. What can you say about the y prime? For the red, negative. Okay, so here y prime negative. Over here, y prime positive. And you have a critical point, that is the turning point where f prime is equal to 0, and that happen at x0 or x1. All right, so again here, you will see the breakdown of the interval based on what? Based on the critical point. On the left, you'll see the y prime equal to 0. On the right, y prime bigger than 0. So as I say earlier, you can break it down, the curve, okay, in terms of what? In terms of intervals, where the y prime is positive, y prime is negative. And the separation point is y prime equal to 0. All right, okay. Now let's be more specific. So if you look at the black curve, the first curve here, we know that that will be the separation of a separation point that will determine the intervals. So now, for this x positive, what is the interval? For what values of x, you know, where you will have the y prime positive? From where to where?
Negative infinity.
I will start from where? You will start from all the way down there. So the interval, since we are talking about real numbers, so the interval will start from negative infinity. And where is the ending point? Where y prime is positive, it will end at what? And at x0. Now, that doesn't include x0. So we put that bracket here, the sign of the, you know, that what you call it, bracket, means x0 excluded. Because x0 is where y prime is 0. So it's up to x0. That doesn't include x0, okay? It will be just near to x0, doesn't include x0. So that will be where your y prime is positive. Now, what is the interval for which your y prime negative? Where does it start at?
X0.
We'll start at x0, but it doesn't include x0, okay? So we start x0 to where? To positive infinity. So that is another interval. Over that interval, the y prime is negative. Okay, all right. So to summarize, we can put a table. Okay, I put the table here. So here you can break it down into intervals. Based on what? The basis of the interval will be what? Will be where y prime or f prime is equal to 0. And suppose that happen at x equal to x0. And of course, you can find the value of y, that is y0. So we don't sometimes, you know, we don't have to worry about the y now, okay? Just worry about the x. So that would be the basis of the interval, where the y prime equal to 0. And then you can break out, all right? You can break out based on that one. You have two intervals. One is negative infinity to the x0, but does not include the x0. That's why you put the bracket like that, x0. Now, if you have a bracket like this, okay, bracket like this, that means include, okay, include the endpoint, include x0. If it's the normal bracket, that means exclude x0. Exclude x0. Okay, so clear now? So the interval that we're talking about would be that kind of interval. So you have that interval, and that interval, if you go back to the graph, so I have the critical point x0. So now interval would be from x infinity to, so you have here the intervals, in negative infinity to x0. And what about the f prime? F prime is negative or positive. Can you see back your graph? For the first curve, positive or negative?
Positive.
Positive. Okay, positive. And then after x0, upward, f prime negative. So that interval, you have positive or negative derivatives, which you can identify from the slope. So betul tak? Negative infinity, positive. So gitu Pak Adi. Negative infinity to 0, positive. Okay. So that is the first, okay, the first curve, the one that I draw in black. Now for the second curve, okay, for the second curve, again here you have the critical point, okay, where the y prime is equal to 0, that happens at x equal to x1. So you have two intervals, negative infinity to x1, and you know the f prime over the interval is negative. And for the other interval on the right, x1 to infinity, f prime is negative. Positive, I'm sorry, negative, positive. Okay, all right. Now, let's go back to the graph. Suppose, okay, suppose this x0 katakan equal to, I have a few more minutes, equal to 5. And let's say this x1 here is equal to negative 2. Don't worry about the negative 2. Just look at the first curve, all right? Suppose 5, okay, we give a specific value. Now you have the interval from negative infinity to what? To 5, okay? And here, 5 to infinity. Again, positive, negative. And for the other interval, I have negative infinity to negative 2. F prime is negative. Negative 2 to infinity. I got f prime positive. Okay. All right. Okay. One more example. So I draw another graph. Now, suppose I have the following curve. Let's draw another curve. All right. Suppose I have something like this. So that is x, y, this is 0. And as you can see here, you have 1 point, 1 point, 1 point here, f prime equal to 0. Suppose that will be equal to x0. And here you got the critical point, f prime equal to 0, or y prime. That is at x1. Okay, now, you look at the critical point, and then I want you to draw, okay, on your graph, the derivative, okay, the slope for the curve, you know. You will see where it's positive and where it's negative. Okay, all right. Okay, now we start with, you start from the left. Okay, start from the left. Okay, from the left, what can you say about the derivative, the slope at the point, at a point?
Negative.
Negative. Okay, to the left of x0, you'll see the slopes are negative. What about here? What about here? Positive. What about over there?
Negative again.
Negative again. So you'll see here, for each interval, you will have the same sign of the derivative. For that interval, it's either positive or negative. Okay. So if you look at this curve here, you have how many intervals? How many intervals can we use based on the point where the derivative is equal to 0? How many intervals would there be?
3, sir.
3 intervals. All right. So here, first interval is negative infinity to x0. Second interval, x0 to x1. Third interval, x1 to infinity. So as you can see, 1 critical point, 2 interval. 2 critical point, 3 interval. Okay. So that's the guideline. So from x0 to, from negative infinity x0, you see here f prime is what? Negative. Over here, f prime positive. Over there, f prime negative. So over the interval, over one interval, normally we have the same sign for the derivative. If it is positive at one point, it will be positive everywhere. Okay? So you have over the same interval, okay, over the same interval, you have the same y prime. Okay, y prime bigger than 0 or y prime less than 0. All right, so it will be the same sign. If it is positive, it will be positive for the whole interval. If it is negative, it will be negative for the whole interval. All right, so for the same interval, it's either y prime is positive everywhere or y prime is negative. Okay, so that is the what you call it, the guideline. So now, okay, what we have learned, we can see or we break out the curve into interval based on what? Based on the y prime. Okay, and then the basis of the interval will be y prime equal to 0. From there, you can break out the point, the interval. That's number 2. Number 3, over the same interval, the sign of the y prime will be consistent. All right. In one interval, either the y prime positive or the y prime negative. Okay. So you don't have, in one interval, y prime negative, y prime positive. So if you have that, that means you have to break out into 2 intervals. Okay. All right. Any question? Good. Okay. So I want you to go home, review the thing that we discussed here. On Wednesday, I will continue. Okay. So make sure you understand a little bit about the intervals, and then the f prime, and for the intervals, and then next time, you want to relate to y. Okay, to the curve, to the function. Okay. All right. Good. So I will stop here. I will see you again on Wednesday. So if okay, ni siapa ni? What is your name? Okay, ni bagus ni. Okay, you put a video so that I can see you. What is your name? Siapa nama? Muhammad Ramadan.
Muhammad Fazal Ramadan, sir.
Okay, Ramadan. Good. Okay, you put a video so that I can see you nicely. Okay. So far there are a few people who put video. So I get it's good. Okay, so I'll see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Thank you, sir.
Thank you, sir. Waalaikumsalam.
Thank you.
Okay.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.
Okay, thank you.
Thank you, sir.
All right.
Thank you, sir.
Okay, thank you.